Hey everyone, welcome to today's lesson having to do with ellipses, which is basically a fancy term, a mathematical term for ovals. Okay, so yesterday we did circles, and logically, what follows is something that's kind of like circles, which is ovals. Okay, or we'll call it ellipse to be mathematically correct. Okay, so this is a slide just for your reference later on. There's a lot going on over here, and I'm going to break it down later. So don't stress out about this at all, because right now it probably looks like a whole bunch of complicated stuff. Okay, so now I actually want to start with circles. Okay, so if we start with circles, okay, yesterday's format looks like this. Okay, this would have a center of 2 comma um, -6. So a center would look like this. Okay, and this has a radius of 3 because the square root of 9 is 3. So I like to go like this, like this. Okay, this is 3 up, 3 left, 3 down, and 3 right. And you can connect the dots to make a circle. Okay, that's the best circle I could draw freehand. Okay, so today's format is going to look like today's format is going to look like this. Okay, so this is just a manipulation of that. Okay, so if you divide everything by 9 here, you're going to get this. Okay, so let me actually turn this into, let me make that green. Okay, and I will make this green. So if you divide everything here, okay, by 9, 9, and 9, these both cancel and you get 1. Okay, this equals to 1, which lines up with this 1 right here. Okay, and then you get a 9 on bottom here and a 9 on bottom there, and that lines up here. Okay, so this is just a rearrangement of what you see. What you see on the right is just a rearrangement of what you see on the left. Okay, and the way ellipses are formatted is going to be like this. Okay, so how do we interpret this? Okay, how do we interpret this? This is interpreted the same, pretty much this a very similar way. Okay, again, the center is going to be 2 comma -6, which lands us here. Okay, now if we square root this, okay, if we square root this 9, okay, we're going to get 3. And we're going to square root this also. Okay, you're going to get 3. And you're going to get 3. Okay, because this is on the x, this is on the x side. Okay, this is going to be 3 left, right. Because this, instead of saying on the x side, I'm going to say because this relates to the x, it affects the x. Because this relates to the y, it affects the y, it's up, down. Okay, so I'm going to go 3 left, right, which goes 3 left, right. And I'm going to go 3 up, down. Okay, and then now you get the same circle as you see on the left side. So the red circle is the same as the green circle. It's just a different way of interpreting it. Okay, here we interpret it, oh, the radius going all the way around is 3. So 3, 3, 3, 3, 3, 3, 3. When we look at it in this format, we interpret it as we go left, right, 3. Okay, and then we go up, down, 3. Okay, so again, it's a different way of interpreting the equation to get the same exact result. Now, what is the purpose of doing it this way here? What's the purpose? Well, let's pretend this was a, instead of a 9 here, let's pretend this was, whoops, instead of a 9 here, rather, I'm going to change this one. Instead of a 9, let's pretend this was a 25. Okay, which means this would be a 5 left, right. Okay, so we'll be going 5 left, right instead. Okay, 5 to the left, 5 to the right. Okay, and again, I'm keeping this, in this example, I'm keeping this as 9, so it's 3 up, down. Okay, so in this particular case, with this new example that I completely made up, you would get something that looks like this, which is an oval, because it'll be 5 left, right, and 3 up, down. Okay, so this is how we're going to interpret it and rearrange the numbers when it comes to ellipses. Okay, so if you want to just be completely consistent, you can always keep the right side as 1 and divide everything by whatever number this is. If it's greater than 1, in this case it's a 9. So you can that will retain the format of the ellipses all the way to that way you're just consistent. Use the same format for ellipses as you would for circles. Okay, so if you want to use this format right here, all I'm trying to say, okay, that was a little bit cumbersome the way I said it. If you want to use this format for circles, that's fine with me also. But most commonly when it comes to circles, they use this format where this number is greater than 1. Okay, but like I said, if you want to use this format and divide, in this case, divide everything by 9 to keep this as 1, whether it's circles or ellipses, that's fine with me. Okay, now if you look over here, okay, here's just some basic vocabulary. Okay, your center here is negative 5, 4 in black. Okay, your vertices is what's on your major axes. Okay, this is called the major axis because it's the longer axes. Okay, this is called the minor axes because it's the shorter axes. Okay, so in this case, your major axis is horizontal. In this case, your minor axis is vertical. It doesn't always have to be that way. It can be flipped around. Okay, if your oval looks like this, okay, if your ellipse looks like this, okay, then that means your major axis, okay, that's a terrible straight line, is vertical, and your minor axis is a horizontal line. Okay, but in this case, major axis is horizontal, minor axis is vertical. Okay, so your vertices are the endpoints of your major axes. Okay, so it's this. Okay, it's the green, just like it's the green here. Your co-vertices are the endpoints of your minor axes, which are in blue. Okay, all right, so how does this equation look like? Okay, it would look like that. Okay, because you have your center. Okay, you have your center right here. All right, remember these numbers right here in yellow should be the opposite of the actual center. Okay, and then when you square root 16, you get 4. Okay, which is 4 left, right. Okay, and when you square root 4 here, you get 2, which is 2 up, down. Okay, all right, so again, when you square root this 16, you get 4 left, right. And when you square root the 4, you get 2 up, down. Okay, and that lines up, okay, with what you visually see. Okay, so that sums up today's lesson, folks. Here are some problems. Okay, right here, I only want you to do the green highlights. Okay, here's a hint for number 16, divide everything by 50. Okay, everything else is pretty self-explanatory. I crossed off foci because you don't need to do that today. We're going to do that tomorrow. Okay, here I highlighted 41 and 43, but you do not need to do it. Okay, all right, folks. Well, thank you for tuning in. That concludes our lesson on ellipses.